I think the idea of representing a school as a progenitor of what's current and exchanging sort of congratulatory at one level and competitive at another level exchanges between people and schools, and maybe some of this is avoidable, but I always thought SCI-Arc in its best sense was separate from that to the extent that it was possible, that SCI-Arc was a more introverted kind of environment. I think that's much less true now. But that it doesn't have to validate itself by demonstrating its connections to places that are supposed to matter, but instead would make a determination based on who was teaching and who was studying what we thought would matter. That doesn't mean it's so insular. SCI-Arc is not insular. I think SCI-Arc's job is to make the people who make the radical, which is different than saying SCI-Arc's job is to dispense some kind of pro forma that makes you radical. I think SCI-Arc is a great place if there are great people at SCI-Arc who will tell you, you can tell me what you think it is, and I probably would disagree. And what I'm interested in is the tension between possibilities.
I think that is important to put in the context too, in the way how these studios are done in SCI-Arc. And SCI-Arc is a peculiar place with a peculiar group of people in which practice in the professional life in relation to the research is a very symbiotic relationship, so it's absolutely crucial. And also, I'm interested that the students are stimulated in that direction. I'm interested that the students, they become people who can lead ideas and not people who will become necessary employees for other people. At least in my own interest, there is a desire of the idea of how you can choreograph and incorporate the accident, or how you can choreograph and incorporate the unexpected into a fairly controlled environment. Some of the students are really good at it and they develop techniques in relation to it. Like that, for example, recently we were working with the idea to produce cuts, and very brutal cuts in the way that it's done into animals and not in the way that it's done in surgery. Or in some cases like butchery and so on have to do with the relation between flesh and bones. So there's a kind of opportunistic development of a technique, which usually we don't tend to do that in the formal project in relation to digital technologies. But at the same time, I would say they're not really that they're not new techniques when it comes to art or architecture historically, but I think put in that context, I think it produces very interesting and kind of unpredictable outcomes. That's one thing. And the other element is, like many of the other people here teaching on SCI-Arc, is we all are invested in our own practices. So for me, teaching is also based on the logic of what I don't know, or what I'm interested to explore, or what I'm interested to go. So this idea of regions and mutilations and external agents of contamination of accident, it comes also for the need of people like me doing working for 10 or 12 years with computers, and so you start to feel the necessity, the desire to produce a certain kind of level of corruption or some level of transformation within the work because you've been doing it for so long. The robotic house that we initiated a year and a half ago, it was initiated under the notion that it's not clear what we can do with it. And I think that's the best attitude to our technology. You have to get it and figure out what you need to do it. But the learning and the production of the discourse happening in doing it, not in predefining it. I think we are in an era of post-manifesto. I don't think you can set up the manifesto first and then figure out what is technology that fit you better. I think it's a much more dynamic relationship.
Where I position like my work and maybe my friends' work or the people whose work I'm interested in respect to a kind of after digital movement. Let's say processes and forms as opposed to, or objects is another way that people have talked about it, as opposed to technology and affects. The way that it ends up showing up in some of the work that I do in my office is currently dealing with sand deposition and sand subtraction and scanning and 3D projection and sort of combining all these things into a kind of real-time design interface or set of design tools. It has its application, but it also is producing all kinds of new and weird things with a kind of real-time, interactive physical model that's based on sand deposition and landform. If you have real-time control over and feedback introduced into a process of representation and fabrication, it doesn't have to be that direction. You don't have to start with a drawing and then produce an object. You can start with an object and produce a drawing and change it and then feed it back through a process of fabrication. And so it doesn't just mean that you're collapsing the distance between something and creating a kind of immediate interface in the way that we've typically dealt with digital environments, and then moving that into the material realm, which I think is fascinating, meaning the robot becomes a kind of physical interface, real-time interface that manipulates a model in the same way that we used to manipulating digital models, right? There's a possibility of completely removing that digital model altogether and dealing with the robot as the sort of production interface. But if you can do that, you can flip the direction of those things, you can squish them together, you can move them apart, you can introduce things into them whenever you want. And that to me is what's interesting about real time. Not that it's the answer to everything, but it's the sort of final problem to be solved in controlling that distance. And once you can do that, everything can be changed.
One of the aspects that I'm most interested in has to do with the geometry question, but in specific terms, the way that there's robotic motion, and again, this curved geometry rather than vectoral geometry. And we're finding that while the robots are incredibly precise, there's also certain particularities and singularities that are only discovered in real time in the lab, and they're distinct from what can be modeled or simulated in the computer. And I think it's the kind of schism between what you can simulate and what actually you can produce in the lab that starts to engage new kind of modes of representation for the students. So we're interested going forward in really engaging those possibilities. Setup of the lab is actually quite unique relative to any other school of architecture. There are 6 robots. They're small payload robots, and there's 3 that are set up in a kind of cooperative organization, and then 2 larger robots that are also set up in a cooperative organization. Several students that were at SCI-Arc who've gone on to become research fellows at the school, they've actually helped to write a kind of a translator, we call it Esperanto, and that translates between Maya and the actual native language Val3 of Stabli Robotic. What's fantastic about this kind of translator is that from a design perspective, the students can stay in a platform that they're primarily comfortable with, where they can animate, they can rig the motion control in Maya, and then that goes through the Esperanto translator and gets executed in real time in the lab through Val 3. And I think that's something that's specific to SCI-Arc and not at any other school.
The idea of bringing robots was the idea of scrutinizing robots, not saying, oh, here's a robot, great, it's the next, CNC machine or something like that. It wasn't like that at all. It was much more speculative. Is it what they say it is? Is it something different? Can we script it in our own way, or do we have to follow a certain kind of pro forma?
We're involved in two primary areas of research. At least the studios I've been conducting have been involved in two areas. The first one is looking at post-digital techniques of representation, and on the other area is synchronous robotics. So this overall research program, those two areas, involve motion control, simulation, choreography, material propensity, and logistics. And that this setup of multiple and synchronous robotics starts to challenge Euclidean space and geometry, in which we have become accustomed to flattening everything. We basically go through a series of techniques of flattening in order to be able to represent material form. I think real-time synchronous robotics begins to allow us to get to work in space, in real time, and with matter in, as you often say, in flux, okay? So that you have a new design environment and shaping environment that approaches real time. And that, I think, offers a very new set of possibilities for design. Exploring some of these other topics would be interesting, and an opportunity to attach them to various kinds of interests in design at SCI-Arc, and especially SCI-Arc's extraordinary capacity in simulation and animation seemed to us to also be something that was very important to keep pushing forward, and that moving that as an interface for robotics, and especially multiple robots working in some form of collaboration, was something that we felt SCI-Arc was really probably one of the very few places in the world that could do that.
We hosted this conference called Material Beyond Materials with the intention of kind of bringing together people in the field and designers, mostly around SCI-Arc, to try and sort of elucidate what, if anything, had composites to do with the kind of future of our industry. And what's interesting in the sort of new flexible composites, which are this tape, carbon fiber or aramid tape, which is a sort of very thin layer that very much functions like a traditional tape, and you can apply in various layers and produce this fantastic array of shapes that could be flat, but it could also take any other bespoke shape, is that the distribution of fibers is not perfect. So they have this sort of custom raw, or not quite raw, but maybe like imperfect finish to it that as it sort of layers up, produces all this fantastic array of of fibers and areas that are basically have less fiber accumulation, that produces to me a kind of complete new different feeling of the way geometry and material distribution can actually take place on a surface. Now, in the context of a proposal for a kind of small pavilion kiosk, We are trying to like systematize the way lines will be arrayed on various ways on surfaces, sort of simple codes, mechanisms, or scripts. But then there are a number of like simple things that happen when tapes or lines, especially when tape has to be distributed over objects that have like creases or like corners. That tape has to kind of fold, and in the folding there are various potential problems or accidents or misregistration that begin to happen, which are potentially interesting to the overall aesthetic of the object.
I guess after 10 years of modeling skills or modeling tools, which I think architects have been looking into as ways to draw and design, lately I've been working much more with the idea of 3D scanning as a way to acquire analog material from the reality. So the point of departure of the studios, generally speaking, is not an algorithmic or mathematical understanding of geometry, but actually it's more the acquisition of real texture and real geometry from analog material, which I think changes completely the shift between a synthetic way of comprehending geometry towards an idea about geometry being the point of departure for new surface finishes. Intricate drawings have a depth to them, although they're flat, they have depth to them because from that drawing you can interpolate three-dimensionality. So I think one of the projects in which the point of departure is the scripting and actually the ordering system of the project comes from an understanding of mathematics being the device through which complexity is generated, and the reading of the drawing, the complex drawing, actually creates the geometry of the building. There is a clear intention to hide materiality and to really have all the pictorial quality operate on the surface. So there is a strong idea of hiding as much as possible the tectonic of the surface and actually not making that being the point of departure of the reading of the geometry. Very often, I think in the past 10 years, most of my work actually has been based on the idea of tectonics and the way in which geometry relates to components and components to the whole, and how that becomes a way of construction and fabrication. But in the forefront, I think tectonic is a more hidden process than an expressive one.
Technology recently became very accessible, meaning recently I'm talking about the last 20-25 years in architecture. But the truth is, most of the big cultural transformations of architecture in architecture history always come through technology, from the Industrial Revolution and the high level of production of steel to prefab, concrete, blah, 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 modernism, and so on and so forth. So historically, always architecture innovation has been associated with technology. This idea that this is a kind of a new problem, for me always seems like a little bit bogus. It's just that technology now is very accessible, is more cheap, and is on the tip of our fingers in everyday life.
Through my work and the work in the school, I've always been interested in advancing the topological surface paradigm. The earlier studies were about emphasizing strong discontinuities by combining multiple ontologies. So the students started working with things that really didn't have much of a connection and tried to create new ways in which assemblages could happen. But the problem there, of course, is that how far you can go before you fall into collage. So I think that it tries to move away from collage as just simply combining difference or connecting different objects into one assembly, let's say. When we did the seminar, the ceramic was treated in a very traditional way. Work with the application of the ceramic onto a surface. I think one example of that is the work of Frank Gehry when he was, in the 80s, when he was working on all these fish lamps. I think what is interesting from that research is that it allows you to work at the unit scale with really small objects and then really think at the building scale. And I think that's so again, ceramics, both how you make the ceramic and how you apply it, and both are the research that we're interested in working on right now. The mocha shells are really fat columns. And what they have is that they're very incongruent. What we're working with is that different ceramic tiles that shift from mosaic to roof tiles. The roof tiles are 3D and mosaics are small and 2D. I think that, let's say, incongruency is in the studio, applied finishes is in the seminar, and then the combination of both is in the MOCA project.
Digital fabrication and the process of making physical things or objects has been an essential part of our process. Because models do a really, really good job in approximating reality without pretending to be reality, unlike renderings that kind of do the opposite. So we use them less as a final product or as a presentation tool, but as a prototype to develop and explore materiality, spatial effects, and color. In my design studio, I've been focusing mostly on computational models of aggregation. And we've worked with this idea of an aggregated figure as a bottom-up system to multiply single primitives into larger, complex geometric forms. And I've used this technique as a means to develop overall massing, aperture, and tectonic articulation of the skin and so on. So the desire here was less about creating homogeneity, but more a sense of incongruency, disruption, and deformation within a larger massing idea. Advances in architecture have always been, at least to some degree, tied to advancement in material technology. And I'm less interested in the performance efficiency of new materials, but much more in a material behavior that is able to create some sort of an effect that goes beyond what the standard palette of architectural materials can do. For example, in our most recent project, we have been working on what we call an animated aperture, which is essentially a window or opening that is constantly in flux without using any mechanical devices. So now this idea of a moving facade or window frame that eliminates mechanical parts altogether and replaces them with a complex mixture of material properties that operate much more on a molecular level and are able to react to environmental forces, like in this case wind, in a much more sensual way. I'm really interested in designing our own materials. And recent development in advanced composites allows us to mix material properties and go from something that is completely stiff or rigid to something very flexible within one material and one component. And a lot of this technology was initially developed for the medical field to simulate joint behavior in prosthetics, for example, and is now slowly becoming affordable and usable in a much more architectural scale.
My vertical studio here at SCI-Arc is called the Imbalancing Active Entropic Architecture, and that studio was dealing very much with a topic that we call synthetic digital ecologies. And the notion of synthetic digital ecologies really is looking at how synthetic systems in architecture can begin to incorporate systems of organic matter. And in that studio, we were really looking at a kind of exhaustion with the purity of geometrical investigation and how we could begin to work with material agency and geometry together. And we were designing prototypes that would begin to transform the local environmental conditions based on water collection and distribution. And finally beginning to look at actuating that with things like Arduino and servo motors, so how we could really begin to incorporate sort of actuating behaviors into these material systems. That we've worked on called the hydrophile hydrodynamic green roof. The proposal is really to look at how a vegetated roof, a green roof, could begin to channel water and begin to become a really performative constituent of the architecture. And then that's coupled with a kind of formal logic where the roof pulls down into the interior of the building, becoming a more immersive space where you really have a chance to engage with that hydrodynamic roof.
Messy computation is the idea that there's really no reason why we need to have clean techniques when using the computer. And I'm really more interested now in moving and shifting in between different software platforms. There are now softwares available that have an immense computational ability, whereas like ZBrush and Mudbox, they still require craft. There's no pushing the button and expecting something to come out the back end. And I would say I don't know if it's a post-scripting attitude, but it's definitely detouring around scripting a little bit. And so that's the area where I'm working right now is kind of bringing back the intuition and finding softwares and different platforms that I can move in and out of freely without really knowing what's going to come out at the end. So what we did last year for Cantilever was take on the idea of composites in a contemporary way. First off, building with composites, it's really difficult because it's like building with fluids. We also wanted to deal with what I call structural tattoos, which is an idea of applying a graphic, which is simultaneously a structural reinforcement area to the piece to increase performance, but also create different kinds of graphic and atmospheric effects on the piece. And of course, it involves molding and molds and tools that you need to form the composite are of course a hot topic right now, and I think one of the biggest hurdles for composite construction.
There is an argument, a general argument, that the only person who is really a radical person is the person who is prepared to countenance the possibility that you could be completely wrong. There are not so many people like that. But what I think, and I'm not saying the school ever is entirely this or almost this, but at least as long as I do this, the ingredient is there. So I would say that the SCI-Arc paradigm at its best is not an affiliation, it's a tension between options or opportunities.